Hello everybody, once again, this is Chris Muslik, your instructor for the Intro to C++ course. Okay. Today I'm going to go through a couple items. The first being I want to cover a couple topics that are in Chapter 1. I would suggest that you read through Chapter 1. It's not a hard read. It's a good introduction to um, programming, not necessarily just in C++, but how programs function. Okay, so it's a really good introductory chapter. I highly recommend that you read it. I actually have access to the book via a electronic copy that I got through the publisher. I think I shared this link back last week when I gave the instructions on how to find the book. So whether you get a hard copy or soft copy or whatever it is you want to do, that works. So I'm going to use the electronic copy in this class, obviously, so you can see what's on my screen. Um, all right, so let's get started. So what I want to do is I want to cover a couple topics in chapter 1 real quick, and then what we're going to do is we're going to go ahead and build a little program on our own using Visual Studio. Okay, hopefully everybody's had a chance to download and install Visual Studio or some other compatible IDE of your choice, and we're going to take a look at that in a little bit. So this is the book, right? Starting out with C++ from control structures through objects, and it's the 8th edition. Let me jump to page 6 real quick. I want to show you a couple diagrams on a few of these pages. First diagram here, this is something that you commonly see in any introductory computer science course, and the idea is that programs are all over the place. All right, we're writing programs for our PC, our laptop, our MacBook, whatever it might be. But programs are written and executed all over the place. So that, you have programs running on your smartphone, your cell phone. There's lots of software, believe it or not, in your automobile. And there's also software places that you might sometimes not think that it exists there. And for example, here in my kitchen, I have a digital microwave over the stove, and every time you plug something in there and you hit the start button, there behind the scenes there's a microprocessor that's running some kind of software. Likewise, if you have any kind of like digital or electronic thermostat in your house, okay, that is being controlled by a microprocessor which has some software written on it. And that's all done, using different types of tools. But at the end of the day, they're just programs. All right. So we're going to be writing programs in this course using the C++ language. So this little figure here, figure 1.6, which is on page 6 of your textbooks, this represents a small area of memory that contains 30 bytes. Okay. So everything from byte 0 up to byte 29, okay, can be addressed here. Now, what does that mean is that each one of these bytes has an address, 0, 1, 2, 3, so on and so forth, up to 29. And some of these bytes have values stored in them. So, for example, the byte that's addressed at number 16 has the value 149 stored there. Okay, so that was, the program wrote something to memory at this memory location and stored the value 149. Later on, the program is going to probably need that value for some reason, so it's going to have to find the value that's at address 16 and extract that value from there and maybe update it and put something else back in there. That's the idea. Likewise, at address number 23, all right, there's a value of 72 that the program stored there. What that value represents, I don't know. But the idea is that your program wrote something to this address, and later on it may need to go back in and read that value and do something with it. So this is a really good diagram which illustrates, sort of how memory is mapped in your machine. And what I mean by machine doesn't necessarily need to be a computer, but whether it's a computer or a cell phone or even any kind of microprocessor, it has some amount of memory that's addressable. Let me jump forward here now to chapter 12. I'm sorry, page 12. And here's another little diagram which I think is helpful for us to understand a little bit more about what goes on behind the scenes with a C++ program in particular. Actually, either a C or a C++ program. So what we're going to do is we're going to enter source code Okay, human readable code. Okay, is going to be entered into a text editor by you. Okay, you're the programmer. That source code is human readable, but the computer and the processor knows nothing about how to read source code in that form. It only knows how to read machine code. So what we're going to do is we're going to enter our text into into source code. All right. That source code will have to be rendered through a couple different processes before we get a final executable program. The first thing that gets done is the source code gets fed into what's called a preprocessor. Okay, the preprocessor essentially will look through your program and find any what are called preprocessing directives, which are almost always things that begin with the pound sign or the hashtag. And what the preprocessor will do is it'll take these little mini instructions, for lack of a better word, and convert them into some kind of source code. Okay, so the preprocessor does all that work for us. What we output from the preprocessor is going to be our source code, but it's going to be modified a little bit because these tags, okay, that have the pound sign in front of them, will be expanded to include the actual underlying code for those tags. Next thing that kicks off is what's called the compiler. Okay, our compiler will then take the modified source code. It does all of its magic, and it will generate what's called object code. It'll generate object code, excuse me, as long as there are no syntactical errors in our source code program. If there is, then the compiler will fail, and it'll generate an error message for you that you have a syntax error somewhere. So what gets generated then is the object code. Okay, the object code is then it's in a binary format. Okay, then what happens is your object code will be fed into another program which is called the linker. Okay, the linker will then take your object code along with other object code that will exist in your environment. Okay, what I mean by your environment is like it's kind of like the libraries that are behind the scenes in Visual Studio or whatever other IDE that you're going to be using. And sometimes it'll even include like third-party libraries if you're trying to connect to a web server or what have you. So essentially what this does is it takes your object code, bundles it together with some other object code, and it'll generate an executable output file, which is the executable code in a format, like for example, if we're working on a PC, it'll be some file that has an extension of .exe in it. So it's the actual executable portion of code that can then be run on that particular device. Okay, in this case here, it's going to be our computers. Okay. Let me jump forward real quick to page 14. Okay. And let me just talk a little bit about what a program is made out of. Okay. So a program will do exactly what you tell it to do and nothing else. So now sometimes you've heard of the old adage that there was get some mistake on your, I don't know, your report card or something like that, and somebody says, oh, it was a computer error. Well, there's no such thing as a computer error because computers are only programmed to do precisely what a programmer tells it to do. There's no ambiguity in there. So what you write, okay, is what you're going to get. If there's any errors, it's not the computer's fault. It's the fault of the person that wrote the software. So let me just talk real quick about some of the elements that are part of all programming languages. Okay, not really necessarily C++, but there's a few of them, right? So the first one is keywords. Okay, keywords are things that are part of the core of the language, and they have a special meaning. Okay, and those keywords are sort of like mini instructions that you're going to be able to utilize in order for you to more quickly create workable programs. And we'll see these in a little bit. The next one is what I call programmer-defined identifiers. These are typically things that you're going to create in your programs that are specific to the application that you're writing. And what I mean by that, it's these are identifiers for your variables, file names, those types of things. So these are things that you customize yourself. Right? Operators. All right. Operators are the things that are going to perform some kind of operation on typically data, whether that's numerical data or string data, and it could be something, as simple as the addition operator, right? You take one value, add it to another value, and you get a result. Okay, so those are what are called operators. We're going to see all kinds of operators throughout this course. Punctuation. Punctuation is sort of like the stuff that we need to tell the compiler, where a particular bit of code begins, where a particular bit of code ends, and there's rules in place for how we use the punctuation within our language, and the punctuation dictates. If you get the punctuation properly, your program will generally be able to compile. All right. And the last thing is what's called a syntax. Okay, and a syntax is essentially it's the rules of the language. Okay, so once you understand and learn the rules of the language, you'll know how to use all those pieces from up above to go ahead and create a fully functional program, whether it's really small and simple like we're going to do today, or a more complex program such as an IDE itself. So that's all I want to do is to go over the book for this chapter. I'm not going to spend a lot of time in this course going through the items in a book like I'm doing right now. However, there are times when I find something that's useful and I'd like to share it with you guys, especially since we're not meeting face to face. I think it's useful for you to understand some of the more relevant aspects of the content of your book. I'm going to pause the video just for a second and come right back in, and then we're going to jump into our IDE. All right, everybody, I'm back. Now what I would like to do is go through a very small program that we're going to create together here within the Visual Studio IDE. For those of you that might be new to programming, an IDE stands for Integrated Development Environment, and what it is, it's a suite of tools that are bundled into one program, okay, which is, in this case here, it's called Visual Studio. Some of those tools that we're going to be exposed to in this course is obviously things like the text editor, the compiler, the linker. Later on in the course, I'm going to introduce you guys to another tool that's works very well within Visual Studio, in my opinion, and that's what's called the debugger, okay, which will help us to debug or fix or find errors in our code. So again, as I alluded to before, you're free to use whatever IDE you want. I know not everybody's working on a PC. Some of you may have a Mac or a Linux machine. Some of you might prefer another IDE. That's fine. For this course, I'm going to use Visual Studio. In this case here, it's a Visual Studio Express 2015 for Windows desktop, excuse me, and it's free. Okay. So what I want to do today is go through, okay, and this is a common thing to do on an Intro to Computer Science class or Intro to Programming class, is we're going to create your standard Hello World program. All right. So if you don't have Visual Studio installed running yet, why don't you just pause this video and then get it up and running, and I'm going to walk you through how you go ahead and create a project, okay, for our little program today. So what we're going to do is we're going to click on the File menu over here. Click on File, New Project. From this dialog box, you can see that there is a number of different project types that we can create. So the default installation, I believe, gives you Visual C#, Visual Basic, Visual C++. I believe if you selected the option, you also get a SQL Server database installed. This is a C++ course, so we're going to use the Visual C++ template. So if I expand this guy over here, Visual C++, I'm going to go down to Win32, okay? And we're going to create a Win32 console application. What does that mean? A Win32 console application is just like your standard command prompt type of program. if we have time later on in this semester, maybe I'll introduce you guys to how to create like a small, Windows application which has like windows and buttons and radio buttons and checkboxes and all that good kind of stuff. But the purpose of this course is to learn the fundamentals, and that is best done through these types of projects, which are called Win32 console applications. So once you select Win32 console application, you need to then go ahead and give the project a name. Okay, so I'm going to name my project Hello World. And some of you already may have done something like this. Right? So that's going to be the name of my project. I'm going to browse to a different location as to where I'm going to put my project. I'm going to use the standard documents directory, so I'm going to go to my documents directory. You can put it wherever you want. Put it on your documents directory or anywhere on your local drive. One thing I would suggest that you don't do is don't ever create projects on your flash drive. It's okay to copy and move them around from your flash drive, but don't ever create projects and run them off of your flash drive. The reason is because when you go through the process of building a program, compiling and linking a program, there's a bunch of files that get rendered behind the scenes, which you typically don't see unless you drill down in to look at them. And I'll do that in a little bit. I'll show you guys where they're at. And it's that reading and writing from a flash drive of those numerous large files, which can be terribly, terribly slow. So again, read off your local drive. Okay. Documents. Sorry. Projects. So I'm going to put in my Visual Studio 2015 projects directory. So I'm going to select that folder. That looks good. All right. Going to click OK. Again, if I'm going too fast at any point in time, you're right. Obviously, you can pause the video and back up and catch up again later. I'm going to click OK. Once I click OK, click through here to go next. And the only one change that you need to make in the last dialog box here is this option here. Okay, so the application type is going to be a console application, and we're going to create what's called an empty project. All right, so your settings should look just like this. Okay, with this radio button and these two checkboxes selected. Now I'm going to click Finish, and that will create what's called like the skeleton of my project. So this is where your source code is going to go. Okay, sometimes it takes a little bit of a minute for it to be created, and there's actually quite a few files that are part of a project. It's not just your source file, but there's other like project type settings. I prefer to have this window and this window over here on the left side of my screen. Visual Studio allows you to customize your interface quite easily. Okay, so this box here is what's called your Solution Explorer, and this is the thing that you're going to work with the vast majority of the time. This other box down here, this is your project properties window. Okay, and this will show you where your the name of the file is, where it's located. Okay, they're just properties of a particular element of your project. What you can do is, if I want to move this around, if you click on the little yellow or whatever color bar this is right here, and you drag this around, okay, if you click and drag, you'll see that you get some options on your screen as to where you can dump this thing. All right, so what I want to do is I want to move this thing over to here, okay, and I'm going to dump it on top of this little box here, and this will now it'll now lock my Solution Explorer to the left side of my screen. Going to do the same thing with the properties window. I'm going to drag that over to here. Hopefully this will work. And what I'm going to do now is drop this so that it's going to sit below my Solution Explorer. And now I have my ID set up the way that I like it. You can set it up any way that you want. This is the way I prefer to do it. If you're moving anything around and you create an environment where it kind of looks all messed up and you don't know how to restore your environment, there's a cool little option that you can select underneath the window command or the window menu option. And if you click on window and click on Reset Window Layout, that'll essentially restore the window layout to um, the way your IDE looked when you first started it up. So it does a reset. It's pretty self-explanatory. All right. So this is my solution. Okay. So the way Visual Studio works is that you have the notion of what's called a solution. Right? So a solution is kind of like a wrapper around one or more projects. Okay. So within my solution, Hello World, I have a project. Okay, which is called Hello World. So the idea is that you can have multiple projects within one solution, and it's not an uncommon thing to do that. What I want to do now is create a source file where I'm going to create my little Hello World program. So what I'm going to do is select a little folder down here that's called source files. I'm going to do a right click. Again, there's other ways to do this. You can play around with this. You can click on right. You can right click and say add. You can click on the file menu and click new. There's different ways to do this, but I'll show you this way. So I'm going to click on file, add a new item. Okay. So my new item is going to be a .cpp or a C++ file. Okay, that is going to be where I'm going to put my source code. All right, source.cpp is fine, but I'm going to call this Hello World typo name .cpp. Okay, so that's going to be my source file. I click OK. And now I have my hello world main.cpp. Now I can go ahead and write my program. So almost all the programs that we're going to create in this class are going to have to include a particular header file that's called IOStream. Okay, IOStream is the header file, or the library sometimes referred to, which will allow us to read and write from the console, meaning that it'll display characters on the console, and you could also use it to accept input from your keyboard. So the way that we include that library is we type the pound sign, or the hashtag, so pound, include. Again, this is a preprocessor directive, pound include. Then you're going to use an angle bracket. Okay, and here you type IOSTREAM, IOStream. I tab away. And now I have my include directive for the IOStream library. So now I have access to all that good stuff that's in the IOStream library. I'm going to hit the Enter key here. The way that the bulk of the libraries are set up in the C++ environment is they're divided into like subsets that are called namespaces. Okay. A namespace is essentially what's the best way to explain this? Like a fully qualified way to access a particular portion of a library. In this course here, we're going to be using what's called the standard namespace. Okay, so in all of our programs, unless I tell you otherwise, we're going to be using the standard namespace, and the way that you access the standard namespace is you type using namespace, and it's std, and here you need a semicolon. You'll notice that based upon some of the elements that I typed into my text editor, I have different colors. Okay, the elements that are in blue, those are your keywords or your reserved words. Elements that are in gray, these are your preprocessor directives. These guys here that are maroon or red, this is just a library, and things that are in black are typically just some other part of the language. Another thing I want to do real quick is let me I guess the zoom on this is okay. Let me just make this a little bit larger for you guys so you can see better on your screen. All right, so now I have some of the setup completed for the beginning of my program. Next thing that we need to do is all programs, okay, need somewhere to start, okay, for lack of a better word, or they need an entry point. Okay, so what I'm going and in C and in C++, that entry point is always going to be called what's your main method or your main function. Right? So I'm going to create a method here that's going to be called main, and it's going to have no return value. Right? So it's going to be a void method. So I'm going to type void main. Okay, open and closing parenthesis. The open and closing parentheses indicate that main is a method or a function. You can use those words interchangeably. Okay? And then you're going to have an open curly brace, and hit the enter key, and then a closing curly brace. Okay. Right now, I could compile and build and link this thing, and I'd have a fully functional program. I wouldn't do anything, but technically it is a fully functional program. Let me just mention some issues with the syntax here. So void tells you what type of function it is. In this case here, it's a function that doesn't return anything. That's what the void keyword means. Basically, it just means nothing. Okay. Sometimes you'll have functions that return values, and main could actually return a value. We'll talk more about later on in the course. The name of my function is called main, okay, and lowercase m-a-i-n. C, C++, and many languages are case sensitive, so lowercase m and uppercase m mean two different things. In this case here, the main method must begin with a lowercase m, and the rest of it needs to be in lowercase also. So again, C and C++ is a case sensitive language, okay, so just beware of that. The open and closing pair of parentheses indicate that it's a function or a method, okay. And then we have the open curly brace and a closing curly brace, and this is the indication as to where the function begins and where the function ends. One thing I'm going to do for you guys, which will make your lives a little bit easier, is I'm going to enable line numbers within my text editor. This way, as I'm referring to some bit of my code, and this is more applicable to the larger programs. When I'm referring to some bit of my code, I'll be able to refer to it as a line number. In this way, it kind of removes any ambiguity. The way that you can turn line numbers on, if you click on the Tools menu option, and you click on the Options command down below, and if we drill down in here to, so if we go to Text Editor, C++. You could turn this on for any other language you want to use, but we're just using C++ here. And I'm going to turn on line numbers. So I'm going to select line numbers. Now I'm going to click OK. And now you'll see that my text editor has line numbers off to the side. These numbers actually don't reside in the file, right? They're just for illustration purposes, so that they're not actually part of the file. Okay, it's not part of the syntax or what have you. All right, so what I'm going to do now is on line 5, what I want to do, the idea behind this program is that we're going to display a little message onto our console window, which is going to say hello world. Okay. I'm sure a number of you guys have already done this in other courses, whether it's Intro to Computer Science or whatever you do in Java or VB, it doesn't matter. Again, this is just like your standard introductory hello world type of program. So what I'm going to use is I'm going to access an element of the IOStream library that's called cout. Okay, so I'm going to type cout here. You'll also notice too, as you're typing within the editor in Visual Studio, and many IDEs do this, you'll have what's called a little IntelliSense menu option that pops up. And what this will do, this is kind of like a little helper tool that'll allow you to pick and choose things from your list of available options. Okay, so here I have the option to select the object that's called cout. Cout stands for console output. Okay, so now that we have access to a console output object, now what we need to do is we need to essentially feed it some data. And the way that we do that is by using the double less than signs or angle brackets, whatever you want to call them. Okay, and that is a way for us to insert something into what's called the console output stream. Okay, so you can think of cout as, kind of think of it as like a pipe. All right, so whatever you put in on one end of the pipe, if you keep putting stuff in there, eventually it's going to come out the other end. So the formal definition of the double angle brackets in this case here is what's called the stream insertion operator. So essentially whatever we put on the right side of that stream insertion operator will be fed into the cout object. What can you put on the right of the stream insertion operator? You can put variables, literals, strings, many other types of objects. In this case here, we're going to provide it a string object, okay? And the string object is going to be fed into the cout object. So I'm going to type a space here, and now I'm going to use a double quote. You'll notice that the double quote turns red. This is an indication that it's a string. And here we're just going to say hello world. All right. So what is in between the double quotes is a string. Okay. Remember, don't use single quotes. You're going to use double quotes. After this string, we're going to use a stream insertion operator again, and we're going to feed it what's called the end line indicator. Okay. And that is ENDL and then a semicolon. Right. Semicolons are an indication that it's the end of a statement. So this whole line, line number 5, is what's referred to as a statement. Okay. That's it. So we have a program right now that will, just once we build it and compile it and build it and link it, it'll create the text hello world to our screen, our console. One thing I want to mention here real quick is this ENDL. Okay, this is sort of a so the best way to explain this. It's like it's an indicator, right, or it's a flag that gets fed into cout, and it just stands for end line. It's the reason why we use this as opposed to some other special characters is that this will create our program to be more generic or cross-platform. So if you were to take this code here and literally copy and paste it into another compiler that was running on a Linux machine or a Mac, you would get the same exact output. Almost everything that we're going to be, everything we're going to be doing in this course is going to be dealing with what's called ANSI C++. So it's kind of like the core standard. So if you wanted to, you could actually compile this across different platforms. Great. So now we have a program. I don't have any syntax errors. We're going to come back into this in a little bit. I'm going to create some errors so you guys can see what an error would look like and how you would go ahead and correct it. So this program won't do anything right now, so we need to go through that process of invoking the preprocessor, the compiler, the linker, and all that stuff until we can generate an executable. One of the great things about using an IDE like this is that it'll do all that for you. Okay. So if I click on the debug menu, the build menu. Okay, if I click on the build menu, you can click on build solution, and that will build your program, which will invoke the preprocessor, the compiler, and a linker, and generate the executable. Or what I commonly do is I hit F7 on my keyboard. So sometimes you might see me, rebuild a program. You won't see this menu pop up, and that's because I typically just use the F7 command. And you could use either one. When it builds, you'll get an output window over here, and it's going to step by step tell you what's happening. So it's compiling the hello world main.cpp file, and it'll show you, if it's successful, it'll show you where the actual output executable is. If we were to go to this directory, we would see a program that's called hello world.exe. And that's the thing that we're going to invoke next. If you were to take this exe and give it to your friend that's running the same type of operating system, it would work there also. Okay. Now what I want to do is I want to be able to execute my program hello world.exe from within my IDE. The way that we do that, if we click on debug, and we can click on start debugging. Or actually, I'm going to click on the other one, which is going to start without debugging. All right, so this will open up a console window for me without bringing it to debug mode. Later on in the semester, I'm going to spend some time teaching you guys how to use the debugger. So I'm going to click on Start Without Debugging, or again, the common command would be used to control F5 key combination, which again I will more commonly do that. So you might see me execute a program, but not see me open up this menu option. So I'll hit Control F5, and you'll see that it opens up a console window. It displays Hello World, and then there's a little option below that says press any key to continue, and this is just there so that we can terminate the console window. So there we go. You have your first fully functional program which dumps some text to a console. Hopefully you all have this working. If not, go back and review this video and then keep working at it until you get this to work. Again, whether you're using Visual Studio or any other IDE. All right, so I'm going to press any key to continue. I'm going to pause this video for a second. I'm going to come back in and generate. I'll show you some syntax errors and show you how we can capture those errors and work with them within the compiler. All right, so I'm going to pause this for a second. All right, I'm back. So now we got a working program. More often than not, when you create a program, especially when you're starting out, you're going to make mistakes. Okay, when you make a mistake, there's two different types of mistakes. The first one is what's called a syntax type of error, and that's where you failed to follow the rules of the language, which will cause the compiler not to be able to create the corresponding object code. Another type of mistake that you'll make, it's easy to make, which we really won't see until later on, are what are called logical errors. And those are errors where syntactically you did everything right, but you did something logically incorrect. Instead of adding two numbers, you subtracted two numbers. Okay, so the compiler will allow you to add or subtract, but if your intention was to do addition but you did subtraction, okay, you generate what you call as a logical error. So let me go through a couple common types of errors that some of you might come across, and then show you how the compiler catches that and how you can go ahead and rectify it. First one is what's a common one that students do. So you create a string, but perhaps you forget to, or you want to create a string, but you forget to wrap it in double quotes. All right. So here the compiler is going to complain and generate an error. So on line 5, what's nice about this version of the IDE, actually most IDEs will do this, is that you don't even need to go through the compile process in order for it to capture the error. Typically, you'll find something like this, and the way Visual Studio does it is puts a little red squiggly line under what appears to be the error. And more often than not, if you hover your mouse over the red squiggly line, it'll tell you what the error is. So here, the error tells us that the identifier hello is undefined. Well, it's undefined. For some of you that might be starting out, that might be a little bit confusing of an error. Basically, what that means is that it's thinking that the word hello is an identifier or a variable, and we haven't declared it yet. Really, what we want to do is have this thing be a string. So what we're going to do is we're going to fix that and wrap this up as a string. Another common error is, and this will come in time, is to know when you do and when you don't use a semicolon at the end of a line. Because you'll notice here, right, I have 6 lines of code in this program, but there's only 2 lines that actually have a semicolon. The reason is because the general rule is that anything that is a statement will have a semicolon at the end. So line number 2 and line number 5 are technically statements. Line numbers 1, 3, 4, and 6 are not statements. In particular, line number 3 is actually what's just called as referred to as white space. All right, so it's just dead space. The compiler doesn't even read or care that that's there. So if I were to inadvertently leave off that semicolon, I'll get an error, and you'll see a little red squiggly line here. But that red squiggly line is now down below here, past my closing curly brace. So in this case, this error is a little bit better of a description, right? It says expected A, and then it says expected A, and then you have in single quotes. It's expecting the character a semicolon. So that's pretty easy to tell by just hovering your mouse over the red cursor. The red squiggly line. But let me go ahead and let me compile this file and show you what the compiler would actually show you as an error. All right. A couple different ways that you can compile a file. You can click on debug and build. Click on build, and you can click on the compile command in here, and compile will compile just the active file. Right? So you might have multiple files within a project. Compile will compile just the current or the active file. Right? So you can hit compile here. You can hit Control F7, which is what I typically do. You can also select your source code over here in a Solution Explorer. You can right click on it and you can click compile here. So there's a couple different ways to do it, whatever is most comfortable for you. I'm just going to click on compile here. And if I do that, you'll see it goes through and it tries to do the compile, but then it generates an error. So here you find out you get an error list as your output. And here we have some errors, right? And if we go ahead and select one of these, and here it says expected semicolon, our program is really short here, right? So we only have a couple lines of code. But imagine if you have many lines of code and you're getting these kinds of errors, well, then you would need to go ahead and maybe go through these one at a time. I always recommend that you start from the top down, because sometimes if you fix sometimes when you fix one error, it'll propagate through and fix multiple errors behind that. Right? So again, I always suggest that you work from the top down. So if I double click this line here, it says expected semicolon. So brings me to this line, and now I can see, okay, I'm missing a semicolon. I know it's up here in the previous line, so if I put a little semicolon there, that error will go away. Okay. Another common error is, some of you might do something like this. Instead of using all lowercase letters for cout, maybe you inadvertently use capital C, O-U-T. And if you do that, get another error, right? Get the red squiggle line that says identifier cout is undefined. And first you might be like, well, why is it undefined? Because I'm including a library. It should be there. Why is it not there? And again, it's because C, C++, Java, and many languages are case sensitive. So uppercase C and lowercase c are two distinct things. So we would need to make sure that we use a lowercase c here. Right? Another common error which I've seen students do in the past, including myself, you do something like this. And what happens is you have your cout object, your stream insertion operator, which takes one operand off to the right, which is going to be my string hello world. But now here I have another operand, which is endl. Okay, so I'm getting an error message here that's saying expected a semicolon. Well, if I put a semicolon in, that's actually not going to solve the problem. What it's really looking for is another pair of angle brackets. Okay, to include this operand to be fed into my stream. All right, so just make sure that for each element that's going to go to for each stream insertion operator, there should be one element to the right and not more than one. Then you can have another stream insertion operator and another element off to the right. So those are some common errors that students make. So that's it for this video. I'm going to post the assignment, or you'll see the assignment in week 2 here. I want you to essentially do the same thing that I did here, and send me a copy of your source code. Again, I know it's super trivial, but if you can get a program like this to work, it's really a big step to know that you have a fully functioning IDE that can use to build more advanced programs later on. So that wraps it up for this week. I'm going to put the assignment up there in a little bit. The other thing too is this doesn't fully cover everything from chapter 1. I'm going to cover a couple small topics later on, and I'm going to say that for next week, and then we're going to drill down into chapter 2. So anyway, that's it for this week, and see you next week. Thank you.